Hello, so this video will be explaining how to solve this question by looking at angles and their relationships with each other. A problem is reported with a section of a track. You are sent to investigate and rush to the scene. When you get to the track, you realize that you have brought a very accurate digital angle measurer, but nothing to measure distance. You notice a straight post making a shadow across the track and measure two of the angles formed before the batteries fill in your measuring device. And this is what you scribble down. We need to figure out whether the railway tracks are parallel by looking at the angles formed. To make things easier, I have already labeled all the points, so now I can confidently say that this line is called line AD, this line EF, and the transversal BG. I've also already named all the angles and calculated the degrees of them all to make things easier. As shown, this angle is called ACB. I have taken the letter of the point of one arm, the vertex, and the other arm to get ACB. We can see that I've calculated this angle as 73.5. This is because of its vertically opposite angle. Vertically opposite angles are known to always be equal with each other. You can also see that I've calculated this angle to be 106.5 degrees. I got this answer because its adjacent angle and it forms a straight angle, meaning they are supplementary angles. And since straight angles are 180 degrees, you take 73.5 away from it to get 106.5 degrees as shown. There are multiple ways to determine whether lines AD and EF are parallel or not. The first one is to look at co-interior angles. To know whether lines AD and EF are parallel, we see whether the co-interior angles are supplementary. Co-interior angles are angles on the same side of the transversal and are on the inner part of both lines on the transversal. Let's look at the angles ACH and CHE to see whether or not they equal 180 together. These angles show to not be supplementary, which tells us that the lines AD and EF are not parallel. The second way to figure this out is to look at the alternate angles. Alternate angles are angles on alternate sides of the transversal. For example, angles ACH with CHF and angles DCH with CHE. With this method, we need to look at whether the alternate angles are equal with each other. But it appears the pairing alternate angles do not, which means that the lines are in fact not parallel. Another way to figure out whether the lines are parallel are to check the corresponding angles. Corresponding angles are angles in the same place on the transversal. For example, angles ACB and CHE are corresponding. It goes the same for angles BCD and CHF and angles EHG and ACH. Once again, we need to look at whether these angles are equal or not. From what we've already seen, it should be obvious by now that the angles are not equal. Let's recap on how to see if lines AD and EF are parallel to each other, depending on the relationships of their angles. First, we look at the interior angles and see whether they are supplementary. In this case, they aren't. Then we have the alternate angles, and we see whether they are equal or not. In this case, they aren't as well. Then we have the corresponding angles, and we see whether they are equal to each other or not, similar to the last one. And out of all of these methods, the railway tracks have failed all of these. Therefore, meaning the railway tracks are not safe nor parallel. Thank you.